Okay guys, so we're gonna go over to chapter 7 and we're gonna do the homework from chapter 7. So I'm just gonna open it up. Chapter 7 textbook. Okay, here. Okay, so we have the textbook right here. Am I streaming? Yeah, I believe I'm streaming. Oops, I don't want that. Okay. So here is the chapter 7 PDF and we're gonna go over to page 455 and we're gonna go over some problems. I think it's 455. Oops, I think I went too much ahead, so I'm gonna go back. Okay, this is the one. So we're gonna start off with number 7. Determine whether the triangles are similar. Now, similar means that all the angles are congruent, but the sides may be whatever, right? But the sides are proportional. So determine whether the triangles are similar. If they are similar, then write a similarity statement and name the postulate or theorem you used. If not, explain. So we're gonna prove how these are similar. So first up, we have these two angles. This one right here, which is FHG, this angle right here is congruent to this angle because of the vertical angles. And angle GFH is congruent to angle HKJ because these are parallel lines. If we think of them extending forever, this will be kind of like a transversal and we'll have alternate exterior. We also have another transversal, which means FGH, which is right here, and HJK is also congruent. So we have these two congruent to these two, and this one congruent to this, K is congruent to F, and we also have the vertical angles. So we have proven all of the angles are congruent to the other triangle. So yes, the postulate we used is AA postulate, and that basically says that if you know that these two angles are congruent, you don't have to prove this with vertical angles, but I just did it because it was there, right? So you could also do vertical angles and then one alternate interior, but anyways, we have at least two. So this will be AA postulate, and they are similar. Now the similarity statement is basically saying, well, like what statement shows that these are similar, right? So our similarity statement would be triangle FGH. I'll actually write it out here. Triangle FGH is similar to triangle, see here, FGH, then that's K, that corresponds to KJ, oops, So KJH, and this is like the little squiggly line, which means similar. Okay, so we can clear that. Okay, so I'm actually seeing how this works. No. Oh god. Wait a minute. I'm gonna get this to work. This is very slow. So I'm gonna trying to print this, so I mean it might be easier, it might not be, who knows. Okay, can we annotate this? Can we? Cannot we? Okay, so back to this one. We're on 455. Okay, so we're on 455, and so we already proven that these two triangles are similar, okay? And postulate we used was a postulated similarity statement was triangle FGH is similar to GJHK. Okay, so these two are similar. Now let's move on to problem 9. Just problem 9. So we have some side lengths right here, 24, 12, 16, and 8. So this one is not about angles anymore. Well, it is, there's some angles here, but it's mostly about side lengths because we have side lengths. So we have triangle, I can draw here. Oh, okay. So we have triangle RST, and we have triangle PST, and they correspond. And we have angle S, which is actually a reflexive angle, meaning they share that angle and they both have that angle. That angle is congruent in both triangles. And we have that angle which is congruent. So wait up. Let's see here. Okay, so what we have here is, remember that we're not testing if these are congruent. So you can't just say that, this, side is, similar to this side, which is probably what you noticed. But we have to see if the ratio between these two is the same as the ratio between these two. So we could do that. So I'll do it like maybe right here. 24 divided by 16 is equal to 12 divided by 8. The other way you would say this, and probably this makes practical sense, but I think might be a little bit more an extra step, would be to add these up to get the full triangle, because we're only taking this segment, right? But we kind of know that this is already included, so these should be proportional for them to have similar sides and angles. So we can add these up, so we can have 36. We have 36 and 24. And the smaller angle side lengths are 24 and 16. So actually I'm just gonna kind of erase that out, and because we'll do this one. 24 out of 36, you have 24 and 16, and we have 36 and 24. So what we need to do is we're trying to see if the corresponding side lengths are proportional. So 24, this one right here, it kind of lines up with the 36, so you have to compare these, which is 24 divided by 36 would be 2/3. So the ratio from this side to this side would be 2/3. Now we have to see if that same ratio is apparent here. So we're gonna do 16 divided by 24. The common factor is 8, so we'll just simplify by 8. And we also have 2/3. So that means since the side lengths are proportional and we have an angle that's congruent, we can classify these two triangles as similar. So I'm gonna erase all this. Now, since we know it's similar, how do we prove this? We did not prove this with angle postulate. We proved this with side, angle, side. We had sides that were proportional, an angle that was congruent, and another side that was proportional. So that was side, angle, side. This one would be side, angle, side. As you're probably right, this one also a postulate. Okay, so now let's go to number 11. So we actually have the angles which are given. So let's first start off by solving for the angle, because we need to prove the angles are congruent, right? So we share an angle 35 right here, so the triangles may be similar, but we also have to figure out this other length. If it's 110, then these triangles are similar. If it's anything other than that, then these triangles are not similar. So let's first solve for this one, this angle right here. So 110 plus 35 will be 145, and then subtract that from 180, and we should get 35. Right, is it right? Yeah, so this one will be 35. And this one, we don't have to check it, but we'll even check it. This one would be 25 plus 35 would be 60, so subtract that from 180. We'll get 120. This angle is 120. So the angles in these two triangles are not congruent. So they can't be similar, because similar means that the angles in them have to be congruent. So let's erase this stuff and let's go to the next problem. Okay, So here we have a proof. Oh no, a proof. So now we have to do a proof here. So I'll do a quick little proof on here, and I'll do it. So I'll just abbreviate it, statements. It's actually supposed to be statements. And then reasons. I don't have to abbreviate it because I already wrote it. So this is given. So I would put this number 1. Yeah, because I don't really want to write it. So then that's given. Number 2. So what we have here is angle ABC, which is this one, is congruent to angle ACD. And we want to prove that these triangles are similar. So let's go ahead and let's prove that. We have these two are congruent, and we also have this angle which they both share because they're right on top of each other. So we can do angle A is congruent to angle A because they share that angle. So they're equal to itself by the reflexive property. So reflexive prop of congruence. And that's number 2. Very sloppy. Sorry about that. That is number 2. Number 3 could be that they're similar because we have 2 angles. Remember, we have this angle right here and this angle, which they both share. So since we know about 2 angles, this other angle has to be congruent to the other triangle. So the triangle in ACD, so this angle right here, it has to be congruent to, well, if we see here, it's D, congruent to C. So this angle has to be congruent to this full thing, okay, even that little bitty space, okay. These angles are kind of like, these triangles are stacked on top of each other, so it's hard to see, but yeah, we know the 2 angles about the 2 triangles. We can conclude that ABC is similar to ACD. It's a weird C over there. By, how do we know this? A postulate. I haven't checked the chat. Oh yeah, I spelled school wrong in the description. Yeah. Sorry about that. Okay, so let's erase this. Just in order. So for this proof, we only had to do 3 steps to prove that these 2 triangles are similar, because we have 2 angles, this one and this one. So let's move on to number 15. So we need to explain why the triangles are similar. Then we have to find the distance represented by x. So here we can kind of infer that they're already similar, we just need to prove it. So let's go ahead and prove it. So these 2 triangles, this one right here and this one, they both have a 90-degree angle. So we know that since all right angles are congruent, these two right angles will be congruent. Also, since there's a vertical angle here, these two angles are also congruent. Now, I think you guys can already tell that we're starting to see two congruent angles in both of the triangles. Meaning, we can prove this by the AA postulate. AA postulate. So those angles are congruent. We have two angles that are congruent, and we know that the triangles are similar. So this one will be congruent to this one. Now, we're not done here. We also have to show what x is. So we have to solve for x. So we know 3 side lengths, and all we have to do is correspond the side lengths with the other side lengths of the other triangle. So this side, which has a right angle and it has that vertical angle, corresponds with this angle because it also has a right angle and the vertical angle. So we can write that as 135 divided by 90 is equal to, we can say that they're equal to because they're similar. So that is equal to x, because 135 is in the triangle of x, divided by 120. So we can simplify this because 45 goes into both. So we can do 3 divided by 2 is equal to x divided by 120. 2x is equal to 360, and we get x is equal to 180. X is equal to 180. Okay. So do you guys have any questions? Okay. So let's have number 17. I'll go ahead and clear up space. Since I literally have, I think I have like 0 viewers right now, I'm gonna post this later. So give me a minute. This might be a bit weird, so I'm just gonna send this. Okay, that's done. Okay, so we have right here, at a certain time of day, a 1.8 meter tall person. Okay, so let's draw a little person right here. It's 1.8 meters, and it stands. Is standing next to the Washington Monument. It casts a 0.7 meter shadow. So I'm actually going to represent the person as a vertical line, and the shadow should be 0.7, 1.8. That's where is 0 there for clarification. And it already showed that obviously these will be perpendicular. They're standing, because they're standing. And we also have the Washington Monument. So the Washington Monument, you don't know this is kind of our X. It casts a 65.8 shadow. So how do we find out how tall the Washington Monument is, which is X in our situation? So what we do is we kind of have to prove that these triangles are similar in order to correspond the lengths to them. So we know that these are perpendicular, so all right angles are congruent because it's standing up, right? And that's a generic thing. We have no other information about that. But you can see here, this is a very similar model, but the person is standing up, and we have kind of like a triangle going on right here. Two triangles here, and this triangle, this angle right here is congruent to this angle because, well, there's like a sun ray, and the ray is reflecting at the same exact angle, so they will have the same angle like that's casting the shadow. So the sun is somewhere here, just pointing that. I think I'm saying a little bit like too complex and in more detail, but that's basically how this triangle formed. It's just formed by the sun rays because we have shadows here. But let's get into the math. So right here next to our perpendicular line, we have 1.8. 1.8 divided by 0.7, which is the bottom angle, is equal to 65.8 over x divided by. This is what we have here. And we're going to do 0.7x because we have to multiply these two because of the property of proportions, that we can cross multiply and you could get the same result, that this one multiplied by this one is equal to this multiplied by this. So let's set up that equation. 0.7 times x is equal to 1.8 multiplied by 65.8. I'm gonna move this guy over here. And we have this equation. I'm actually gonna use the calculator to figure this out because we have some not so great looking numbers. So we have 1.8 times 6.58. 6.58. We have 11.844. Now we need to divide this by 0.7. So x is equal to, let's figure it out right here. X is equal to 69.2. Okay. So, hold on. I think there's some mistake, I believe. Wait a minute. How is that possible? Okay. Wait, guys. We have 1.8. Oh, I think I know. So, I think I did this errors. 1.8 times 6.58. Oh, I did it again. 1.8 times 65.8. There we go. So we should get a more accurate answer this time. 169.2 is how tall. Sorry for that mistake. I caught that mistake because, it doesn't work. This X angle has to be bigger than this because of the proportional. Because since this is bigger than this has to be bigger than this. So 169.2 is our answer. Okay, back into similarities. Okay, so can you conclude that the triangles are similar? If so, state the postulate or theorem you use and write a similarity statement. If not, explain. Let's see if anyone's here. Oh, okay. Can you conclude that the triangles are similar? Let's see. So these triangles, we have STM, this one right here, and we have STM, and we have LNM. So we want to prove that these triangles are similar. So since we don't really have any knowledge about the side lengths of this triangle, we're probably gonna be looking toward finding two angles that are congruent and then proving that they are similar. So we have a great deal of information right here because these are parallel lines, meaning that they are going to have some special properties that no other lines have. So with parallel lines, this transversal right here is going to have alternate interior and alternate exterior, but we can't really use the alternate interior and alternate exterior, so we just have to go with same side because that's inside the triangle. So we know that this would be supplementary to this. So we have this angle which is supplementary to this one. We also have this angle is supplementary this one, right? So we need to prove the two angles are congruent. Actually, let's first start off with angle M is congruent to angle M. We know that, right? So that's one of our angles we have. And actually, to think of it, we can't do same side because, they're supplementary. We don't really know about information about supplementary. But what we can use is corresponding sides. With parallel lines, there's a theorem known as corresponding angles theorem, which states that this transversal, these angles will be congruent. These angles will also be congruent. So we have proved 3 angles are congruent. We only needed 2, by the way. So, if you're getting confused that you need 3 angles that are congruent to the other side, no, you only need 2 angles to prove that they are similar. These 2 angles are similar. Now, the postulate or theorem we used was, we use AA postulate, and we also kind of used corresponding angles, but I'm not sure if that is on the answer key. I think I'll go double check on the answer key. So we're looking for 455. Okay, so yeah, so as I suspected, they are not going to be looking for the corresponding angles theorem because that's something we learned before. And since we're in chapter 7, we're going to be only focusing on a postulate. But this is one of the things we use to prove that the two angles are congruent. Okay. And also, if you didn't kind of notice, we're doing the odd ones because there's an answer to it. So it'll be easier for me to check, my answers. And I only did the odd one, so yeah. Because we're also going to be skipping some questions here and there. So let's move on to page 465. The set of problems I want to do. 465. Now this is, I think it's going to be a step up from what we did before. What we did before was kind of fairly simple. So we have write a similarity statement relating the three angles in each diagram. So here we have this altitude triangle because there's a perpendicular line going through that line. And there's a perpendicular line going through this. So we have two altitudes. Now, when we have like these types of situations where there's like two altitudes, we have like 8 problems with 2 altitudes. And the thing we know from this type of diagram is that all the angles, all the triangles that are visible are congruent. So that includes angle J and K would be similar. Okay, similar. I keep messing up. J and K, and we also have to show the correspondingness, so we don't like just put all the letters in different places. The order matters. So J and K, let's do K and L. So J N, L and K. Pretty sure L would be the one from. Okay, so L would be this one. L would be this, and we have N, and we have K. That leads us to our final angle, which is J. Is that right? Is that J? So the angle with the hypotenuse and the bigger length, J and K. You have to be very careful with this. JK. Let's see here. Okay. You have J and K. So let's actually twist this. I'm gonna be separating this. And we have N right here. And we have K. And we have J. So J is actually congruent with the biggest angle we have here. Not this one, this is K. It's congruent with this angle, J and L. Since J is congruent with this J from J and K, it will be right here. And N, K, these two, which I believe it is not how this is supposed to go. Oh, because they're both N, okay. So that will be J, K, L, if you can see that. So I think the answer key says it different, but these two all three triangles are similar. Because, well, we have the big angle, biggest triangle, the whole triangle is this. We know K is right here. J is congruent to itself. So this J, this whole triangle right here, shares the angle with J and K. So those two angles are congruent. Now the small angle right here, the small triangle, it also has a 90 degree because it's linear pairs, because it's on 90 degrees, 180 minus 90 degrees. And this shares the angle with this biggest triangle, which is L. Okay, so they both share, the small triangle share two angles with the biggest triangle. But the thing is, since we have two angles that are congruent with these two angles, this third angle will also be congruent because of the AA postulate. Remember, we don't need three angles, we only need two, as you know I said before. So this angle will also be congruent to this angle. Okay. K, L, and I know it's hard to visualize it, but that's like the best I can really explain it. So similarity statement is J and K is similar to K and L is similar to JKL. I'm kind of like double checking, you know. Yeah, so those angles are similar in this. 11, same thing going on here. It's basically the same thing. We're just, labeling it differently. It's kind of a tilted and stuff. So we have triangle MPO is similar to triangle OPN. It's pretty far distance right there, but that's congruent to triangle. That's OPN. That's congruent to triangle MON. That's kind of the smaller side. O is kind of the smaller side. Yeah. So those three triangles are similar. Okay, moving on to geometric mean. So I know there might not be any viewers on this stream right now, but if this does go on YouTube, then there will be comments, and I'm gonna try my best to answer all the comments. Okay, so find the geometric mean for each pair of numbers. So 13, we're gonna go with this one right here. Find a geometric mean. What does geometric mean mean? Okay, so geometric mean is the square root of AB, right? So we have two numbers, and the mean of those two numbers is just, if we multiply those and we square root. The algebraic mean, which many of you may know, is A plus B divided by 2. Yeah, that's average, but basically that's what mean is, right? It's the average. So it's the geometric mean. So we have these two numbers, 3 and 48. So we're gonna multiply. So let's get out our calculator and start multiplying these numbers. 3 times 48 is 144, and the square root of that is 12. So that geometric mean for this one is 12. Let's go to number 15, where we have 9 and 7. So the square root of 7 times 9 is square root of 63. And, well, actually, let's erase that here because this is actually not a perfect square. Almost is. But 7 times 9, we can simplify this as a radical. The square root of 9 is 3, right? And the square root of 7 is square root 7. So that's how we can simplify 7, the square root of 7 times 9, which is 3 root 7. I'm just double checking it. Yeah, I think on my actual thing I did the wrong problem. But that's okay since I already fixed it on stream. I'm gonna just check it. So, wait up, guys. Hold on. Okay, so yeah, I'm just gonna do something real quick and I'll be back with you guys. Okay, does that sound good? Sound good. Okay. Do. Okay. So that's 3 times the square root of 7. Now let's move on to number 17. 4 times 49. So we take the square root of 4 times 49. I feel like you can already see that since, you know, they're both squares, the product of the squares will be another square. So regardless, we'll get our calculator back and do 4 times 49, which is 196. The square root of 196, which is, if I use my calculator again, 14. This would be equal to 14. And in algebra, you may have learned, well, hey, the square root of, you know, a positive number, there's actually 2 square roots. So shouldn't it be positive and negative? Well, no. And when we're dealing in geometry, we don't usually deal with negatives. So we're only taking the positive square root of the geometric mean. So knowing that, let's just move on to the next problem. Solve for x and y. Now, the way we're gonna solve for x and y is, oh yeah, it's on here. So we know that all the triangles in this are, the angles in the triangles are congruent, so they are similar. So we can use that knowledge, in this knowledge, to show that all the triangles here are already similar. So we can use the corresponding side lengths, and since the corresponding side lengths are proportional, we can actually solve for x. So let's get started. Okay. Let's do number 19 because, you know, we're doing odds. So we have 40 right here and we have 50. So this one is obviously going to be 10. Now we have a situation right here. We have x divided by 40, this side length, divided by this side length, and we're gonna compare that to let's go with this one. So we're gonna use some corresponding properties here. This is kind of the smallest length in this triangle, I'm kind of assuming, right? So x divided by 40. So the side which is reflexive right here and has that right angle would be x, and 40 is the side which has a right angle, it's not the hypotenuse. So this small triangle right here, we're only comparing the legs because we have compared the legs, would be x and 10. So wait, so if we're doing the corresponding lengths of both triangles, x would actually not correspond to itself. Here's why. Because this angle right here, this triangle right here, if you flip it around, then only it'll be similar. So technically 10 divided by 40, actually it's 10 divided by x, sorry about that. 10 divided by x, I'm actually going to separate it to better explain it. I believe this is, I want to make it so, have this. Okay, so this is the small triangle, I just rotate it to the left. So we have, this is x, this is 10. Now this bigger triangle right here, right, this triangle, I'm gonna also flip it around so it's the same size. It's the same like orientation. This one would be x, kind of flipped over, but if you can virtualize it, this one would be 40. So 10 divided by x would be equal to x divided by 40. Whew. Now this situation which we have right here is where we use the property of geometric mean. The geometric mean of 10 and 40 would basically solve x. The geometric mean of 10 and 40 is what we are solving for. So it's basically the square root of 10 times 40, which is 10 times 400, which would simplify to 20. So x is equal to 20. Now we still, oops, wrong triangle. So x right here is equal to 20. I know that it looks like I'm pointing to y, but it's actually pointing to x. Now what we need to do is we need to solve for y. So the way we would solve for y is we are gonna take this small angle and we're gonna take this big angle. So we're gonna take the hypotenuse or whatever, I don't know. So this big angle hypotenuse is 50. So y divided by 50 will correspond to 10. The short angle would be x, And since we know x is equal to 20, we can put that there. Wait a minute. I'm gonna double check here because I feel like there might be some complications here. Oh, wait, no. No. Y would be the side of y. Oh, okay. So I'll actually draw this out so it makes sense, so you kind of see what I'm seeing. So this is the big triangle. This is the big triangle which we used in our previous thing to solve for x. This big triangle has this y. This would be 50. Okay, we don't really know this. That's not necessary. And this is our small angle. So the small angle would be here. That would be y. And this one would be 10. We're going to pretend we don't have that x there. So the hypotenuse, we're going to divide this by 50. Okay? So once we divide that by 50, that's going to be equal to this length, which is the length next to, like, vertical to the right angle one. And we can actually, to show that 10 corresponds to y, I can actually draw some angles out. So we drew angles here, and the angles show that this big angle, this angle right here, would be similar to this, the small right angle triangle one. So that angle would be congruent to that angle. So the side we're talking about is the 1 and the 90 degree. So that will be 10 and y. So 10 divided by y is equal to y divided by 50. The geometric mean would be 50 times 10. And you can obviously prove the geometric mean by saying, hey, y times y is equal to y squared. 10 times 50 is equal to 500. And y squared equals 500, so y is equal to square root 500. So let's actually write square root 500. And then we simplify that radical from there. Yeah. So, we could easily say 100 times 5. Our radical would be 10 times square root of 5, which is equal to y. Y equals 10 times square root of 5 for this problem. That was a lot of math, so I'm going to clean a lot of this up. Okay? Okay, so hold on. Okay, so number 21 is another problem just like this. Oops. How do I? Oh, okay. So number 21 is another problem just like this. And we have this situation right here. So what I would do, which would be best, is to try to separate the triangles out. This would be this triangle right here. Okay, so that one would be y. x 9, that'll be 90 degrees. And the big triangle right here will have that 90, right? And it'll also share that angle, so this angle. Yeah. Okay, so we know that these two angles are congruent. Now we're gonna see this triangle right here. Okay, 90 degrees. These both share the reflexive angle. We're gonna double tick that because we want to tick this one. And boom, we have this triangle is similar to this. This triangle is similar to this. Now, since this triangle does whatever, has the same angles as this, we can show that this has the one tick mark and the smaller angle at the double tick mark right here. Okay, now into the math. We have y x 9 and we have x 7 and we have an unknown. We have y x 9 here, and for the big triangle we have 16, 9 plus 7 equals 16, and we have y, and we have the unknown one right here. Okay, so so what we can see from right here is that the 16 would be the hypotenuse, so we're gonna go with doing this part. So 16 is the hypotenuse for this angle. The hypotenuse for this smaller angle, which I marked right here, would be y. So big angle divided by the smaller angle, which corresponds to it, it's also hypotenuse, is equal to, let's pick a side. Let's pick this side, which has the right angle and the one tick. So big angle, right angle, one tick. This is right angle, this has one tick, so this is 9. There we go. We have another geometric mean where we have the same variable here. Square root of 16 times 9. And I did that very fast, but it'll end out to be here, calc 16 times 9, 144, and the square root of 144 is 12. So the geometric mean will end up to be 12. So y is equal to 12. Okay, now how about the x? Well, the x, we can use these two triangles because this contains the x. And also this contains the x. We can actually use these two triangles because they have different similarities between them. They're both similar, so we don't even have to use a big triangle here. I'm gonna go ahead and use the small triangles. This triangle and this triangle. What do we know? So the side with, I need to double check that. Okay, the side with 90 degrees and the double tick is x, which means x is equal to x corresponds with 7. So x divided by 7, because it corresponds with that, is equal to 9 divided by x. Is that right? So we have the right angle and one tick. Right angle, one tick. This is x. It's right here. And this is 9, right angle 1 tick. So yeah, the geometric mean of 9 and 7 would be 3 root 7. That will be equal to x. And y we proved earlier was, I believe, equal to 12. I'm sorry I erased that, but that was, you know, the 16 by 9 situation. So 16 by 9 equals 12. So that's where we got the y from. I think if you skip backward, you'll see it. Okay, so we know y is equal to 12, and x is equal to 3 times square root 7. Okay, now 41. 41 is actually a pretty algebraic one. We have to do a lot of algebra here. So we have the same situations, but we have more variables than numbers. So let's get started. But we only have one variable, so that's good. I know the triangles are similar. Let's take this small triangle, and I would take I'll just take the other small triangle. Okay, so I have two triangles right here, right angle, and this one also right angle. But because of what we know from earlier, this one won't be congruent to this. As you can see here, we can congruent to this, and this one congruent to this one. If you ever have to prove it, you can just use this big angle to see it and, you know, start making some comparisons, but that's what we know so far. X plus 5 is this one is also x. This is 20. X plus 5. Okay, so the angle, we're gonna start with the one which has a right angle on the 1 tick. So the right angle on the 1 tick, this side right here, we're gonna go with the bigger side, this bigger angle. X plus 5 divided by x, because they're corresponding, equal to 20 is right here, double tick and right angle. So double tick and right angle, it shares x plus 5. So we also have another geometric mean with 20 and x, but it's 20 and x. How do we figure that out, right? So we actually have to do some algebra here, because we can't just use the square root thing. So we'll multiply these two. 20x is equal to x plus 5 squared, which is x squared plus 10x plus 25. Then we minus 20x from each side, and we get x squared minus 10x plus 25. And this is a very factorable equation. We can factor this into x minus 5 squared. Okay, so x minus 5 squared, remember we have a 0 here, is equals to 0. Take the square root of 0. Get x minus 5 equals 0. X is equal to 5. Okay. So we know that x is equal to 5. Okay. That's also, I think I skipped a problem in my notes. But let's erase this. So we want to leave some room for 39, which also might be a lengthy equation. I don't believe so. So let's just check it out and we'll move on to the other problems later. Ooh, there's a lot of erasing. Okay, actually I'm gonna end this stream right off, but yeah, so I hope you enjoyed this video. I'm probably gonna make this private or not, I'm not sure.